And from this table 3.1, index of refraction of yellow sodium light, wavelength is 589 nanometer. For example, is our water. For its solid phase, the ice, it has an index refraction of 1.309 and is much more lower kesa kay water na liquid form siya, 1.333. Okay? The index of refraction of air at standard temperature and pressure is about 1.0003, and we usually take it to be exactly unity, or 1. The index of refraction of a gas increases as its density increases. For example, is si water natin na liquid and si water natin na solid. Although they are the same water, kapag si liquid water naging ice, it will have lesser density. Kung napapansin niyo yung mga natutunaw na ice, they float because they will have lower density, and thus mas high density si water, si liquid water, and so sa index of refraction, mas mataas yung index of refraction ni water kesa kay index of refraction ni ice water. Most glasses used in optical instruments have indexes of refraction between about 1.5 and 2. A few substances have larger indexes. One example is diamond with 2.417. Let's proceed. Index of refraction and the wave aspects of light. We have discussed how the direction of light ray changes when it passes from one material to another material with a different index of refraction. It's also important to see what happens to the wave characteristics of the light when this happens. First, the frequency f of the wave does not change when passing from one material to another. That is, the number of wave cycles arriving per unit time must equal the number leaving per unit time. This is a statement that the boundary surfaces cannot create nor destroy waves. Second, the wavelength of the wave is different in general in different materials. This is because in any material, the speed is equal to the wavelength times the frequency, and since it is the same in any material, like in a vacuum, and is always less than the wave speed c in vacuum. Wavelength is also correspondingly reduced. Thus, the wavelength of light in a material is less than the wavelength of the same light in vacuum. From the above discussion, frequency is equals to speed of light over the wavelength is equals to speed of the material over the wavelength, or speed of, like for example, the material is air over the wavelength. And combining these equations with equation 3.1 na index of refraction, we find a new relationship of wavelengths. So the final wavelength is equals to the initial wavelength over the index of refraction. When a wave passes from one material into a second material with larger index of refraction, so that the second material index of refraction is greater than the first material, the wave speed decreases. Okay? Wave speed decreases. And the wavelength is, for this relationship, the wavelength in the second material is then shorter than the wavelength in the first material. Comparing the first material and the second material, if malaki yung second material for this relationship, pag malaki siya, ibig sabihin maliit si wavelength B. Okay? Pag naman maliit si A, NA, malaki si wavelength A. Okay? So, if instead the second material has a smaller index of refraction than the first material, so that NB is less than NA, then the wave speed increases. The wavelength in the second material is no longer than the wavelength in the first material. This makes intuitive sense. The waves get squeezed. The wavelength gets shorter. If the wave speed decreases and gets stretched, the wavelength gets longer, and if the wave speed increases. Okay, in short layman term, kapag daw si wavelength gets shorter if the wave speed decreases. And the wavelength gets longer if the wave speed increases. So, kapag halimbawa dito nasabi ko kanina, from this reference na si material B is greater than material A, material B is greater, so the wavelength is shorter. Big sabihin, si wave speed is decreasing. Okay? From NA to NB. Kasi nga, makapal or mataas yung index of refraction ni NB kaysa kay NA. Next is kapag si NA naman is maliit, wavelength niya is malaki. So as to its wave speed, magi-increase. Comparing this material, for example, si NA is air, tapos si NB is water, NA is 1 and si water is 1.333. Okay? Na-imagine nyo na ba na wavelength is directly proportional to the wave speed. So, kapag shorter si wavelength, si speed is lumiliit or nagre-reduce or nagde-decrease. Okay? Learning Activity 3.1. Reflection and refraction. In figure 3.11, material is water and material is gas. So, dito, ang A natin is si water and ang B natin is si glass. From table 3.1, the index of refraction of water is 1.333 and the index of refraction of glass is ano bang ginamit dito? Hindi sinabi anong glass. So, 1.52, i-compare natin siya dito. It's a crown type of glass. Typical values ng crown glass is 1.52. So, from this figure, so dito tayo mag-base sa figure. Okay? The incident ray makes an angle of 60 degrees Celsius. Where's the incident ray? See? Ganon. Kung saan pupunta yung point, si incident ray yon. Sa kanya manggagaling yung ray. So, si incident ray makes an angle 60 degrees with the normal. Ito yung ating contact surface. So, ang normal natin is perpendicular kay contact surface. Okay? So, ganyan siya. So, si incident ray natin makes an angle 60 degrees with the normal. So, that is why 60 degrees with the normal. Next, find the direction of the reflected and refracted rays. Where's the reflected ray? Dito. From incident, ni-reflect niya, and from incident, ni-refract niya. Okay? So, incident, reflected, ano yung theta, or yung angle ni reflected rays, and ano yung angle ni refracted rays from the normal. Okay? From the normal. Now, this is a problem in geometric optics. We are given the angles of incident ray na 60 degrees and the indexes of refraction. So, we must find the angles of reflection and refraction. To do this, we use equation 3.2 and 3.4 respectively. So according to equation 3.3 at 3.2, the angle the reflected ray makes with the normal is the same as that of the incident ray. So theta is just equal to, the reflected theta or the reflected ray angle is just equal to the refracted ray angle. Reflected ray angle is equals to refracted ray angle. I'm sorry for my error. This is the incident and the reflected ray. So, the incident and reflected ray has the same angle. Okay ba? From the second law. I'm sorry with my mistake. Balikan natin. Sana yun. So, the incident ray angle is equal kay reflected ray angle. Close to ng ating laws of reflection and refraction. So, it was my mistake. I am sorry. Let's continue. Now, again, theta r is equals to 60 degrees also. To find the direction of the refracted ray, this theta b, we use equation 3.4, yung ating NA sine theta A is equals to NB sine theta B. And we are to input the values. So, sine theta B ang kailangan natin in this side. So, ibababa natin si NB. It will become NA over NB times sine theta A. Input the values for NA, 1.33. That's the water. And 1.52, the glass. Sine of 60 degrees Celsius. Sine of 60 degrees lang. Equals 0.758. Okay? That is not yet the angle. So, theta B is equals to arc sine. Kabaliktaran ni sine is arc sine. Arc sine of 0.758 is equals to 49.3 degrees. The second material has larger refractive index than the first. What is the second material? The glass. Hence, the refracted ray is bent toward the normal. Hence, the refracted ray is bent toward the normal. So, that's it. By solving this, NA sine theta A is equals to NB sine theta B, and by also this arc sine, we will have another topic for this one if you would like to ask how to solve it using your scientific calculator. But definitely, it is just a matter of practicing on how to use your calculator. So, madali lang tong sundan and gawin using your calculator.